Okay, class, welcome to part 2 of the video for 3.1a lesson. We are now going to go skip to the last page, page 10. We're going to go ahead and finish off this lesson by showing you how to do the last 4 problems. Please follow along and please remember to take notes diligently, right? These videos are only helpful if you follow along and practice along with the video. Okay, so number 14, again, our goal is to isolate y. We always want to isolate y because isolating y gives us the answer in slope-intercept form. Okay, so what I'm going to do is if I want to isolate y, I have to get rid of this x, right? I have to subtract x from both sides. And then you realize that the x values actually cancel, and then you get 2y is equal to -8. Okay, it's a little bit of a special situation, but we're not intimidated. We're not scared. We know that you can have an isolated y equation without any x in it. It just means that your equation is going to be a horizontal line, right? So our equation is y equals -4. Our slope is, well, let's just see what y equals -4 looks like. Y equals -4 really just means to go to -4 and plot every point that has y equals -4 in it. Doesn't matter what x it is, it's going to have y equals -4 in it. And that tells you that it's a horizontal line. Okay, so in this case, you can see a horizontal line has no rise. It is a 0 slope. It does have a y-intercept here. The y-intercept is at 0, -4. Okay, please make sure you understand this kind of unique situation. Okay, so let's go to 15. So this one should make you feel excited. You're like, oh, I see a cross multiplication opportunity. I've been doing this for a while now. I know to cross multiply diagonally, and make sure you don't cross multiply to the point where you can't see the problem, which is kind of like what I did here. So I'm going to make sure, I think that says 1 minus y. So I get 3 minus 3y when I diagonally multiply. And then I set that equal to 2x times 2, which is 4x. And 3 plus times 2 is 6. Okay, so wow, this situation is not very clean at all. You still have a lot of steps that you have to continue to do before we have an isolated y. So I'm first going to get rid of the constant. And I get -3y is equal to 4x plus 3. You can see how many steps I'm showing. Take pride in the work that you're showing because you're putting in a lot of effort for this question. You might as well, do it neatly. Final answer, you can see, is 4 divided by -3, which is -4/3 x. And then 3 divided by -3, which is -1. Got to be careful here. This is a really tricky question. Was not that easy. Let's do a recap. I cross multiplied to get 3 minus 3y, and I set it equal to 2x times 2, which is 4x plus 6. I then subtracted both sides by 3 because our goal is to isolate this y value. When I got -3y equals 4x plus 3, I then divided both sides by -3, and this was my final answer. Okay, -4/3 x minus 1. So let's go ahead and graph that. We know that this is our y-intercept. So you start at -1 at the y-axis, and now I'm going to go down 4 with a run of 3. So 1, 2, 3, 4. 4 down. 1, 2, 3. 3 to the right. 4 down again. 2, 3, 4. 3 to the right. Okay, let's do a reverse one. Up 4. 3 to the left. Up 4. 3 to the left. Once you have a fair amount of points, you then can connect them and you have your equation. Notice how my graph is negative. My line is heading down. As x increases, y is decreasing. Maybe you want to write that. It's kind of fancy, but as x is increasing, y is decreasing, which proves that this slope is negative. Okay, moving right along. Let's go to number 16. You could see that there's a lot of messy fractions in the equation if you want, and I would totally suggest this, but let's go ahead and just multiply everything by 2. Maybe this will make our life easier. Maybe it will be the same difficulty. Who knows? But I get 2y minus x minus 6 is equal to, whoa, interesting, 2y minus 7. Now, why do you think I said that this is very interesting? Does anyone see what I see? If you notice, there's a 2y on the left side and a 2y on the right side. And if I subtract 2y from both sides, first of all, why would you do that? Well, it's because I'm trying to get the y's on one side. Second of all, it's because we have the same amount of y's on both sides. So unfortunately, the y's are going to explode and go away. You then get negative x minus 6 is equal to negative 7. So what's interesting about this is all three terms are negative. So essentially, I can multiply the entire equation by negative 1 and make them all positive terms, right? X plus 6 is equal to 7. And you can see how this was a module 1. This entire page, this entire lesson really had elements of module 1. So if you are struggling with the speed in which I am isolating the variables, you may have to go back to module 1 and just brush up on your skills of how do I isolate, how do I clear things, how do I clear decimals, stuff like that. You end up getting x is equal to 1 in this case. And we know that when you have an isolated x, you literally just go to wherever the x value is and you graph that. Your equation is x equals 1. And your slope is undefined. Can't have unlimited rise with no run. Your y-intercept is none. You don't even have one. Now, please don't write 0, right? A y-intercept of 0 is totally different than a y-intercept that does not exist. Okay, I'm going to do things a little bit differently for number 17. I'm going to have fun with it just because it's the last question. I hope you enjoy this question. Let's multiply the entire equation by 100. Now, I multiplied by 100 and not 10 this time because I wanted to move the decimal 2 placeholders to the right. I end up getting 15x minus 45y is going to equal 0.9 is actually 90. Okay, so I'm going to do something fun. And do we notice the GCF of all three terms? The greatest common factor of all three terms? If you see what I see, go ahead and try this problem. But go ahead and divide the entire equation by the GCF. Does anyone know what the GCF is? If you said 15, you are exactly right. All three of these terms share the factor of 15. So I end up getting x minus 3y is equal to, what's 90 divided by 15? That's 6. Okay, you can see how that made it a little bit easier. Although you can argue I didn't have to do that as a first step. But okay, so now I'm going to subtract x from both sides. I get negative 3y is equal to, again, I like to put the variable in the front because that's what slope-intercept form asks for. Then divide both sides by negative 3. And you get y is equal to, got to be careful here, negative x divided by negative 3. This is a double negative. Negative x divided by negative 3 is exactly 1/3 x. 6 divided by negative 3 is negative 2. Always want to double check. Let's double check really quickly. x minus 3y equals 6. Subtracted x from both sides. Put the negative x in the front. Divided both sides by negative 3 just to cancel this coefficient. And I ended up with 1/3 x minus 2. That works. Okay. Make it a habit to double check your work. So start at negative 2. And then rise 1 and a run of 3. Rise 1 with a run of 3. Give me a reverse 1. Down 1, left 3. Maybe another one. Down 1, left 3. You can see that this slope is flat, but it is still positive. And there you have it, class. That is a slope-intercept form. Thanks for watching.